recurrent networks read a sequence one step at a time and forget the distant past? What if instead every word could look at every other word directly and decide for itself which ones matter? That single idea, attention, broke the bottleneck and became the engine of every large language model. Let's build it. Here's the shift. An RNN passes information down a chain, hop by hop, so distant words barely connect. Attention throws out the chain. It lets every word reach across the entire sentence in a single step and pull in whatever is relevant. Near or far, it's the same distance. No more relay, direct access to everything. The core question attention asks for each word is, which other words should I pay attention to? It assigns every other word a weight, high for the relevant ones, low for the rest. Then it builds a new version of itself as a blend of the words it cared about, context gathered on demand. But how does it decide those weights? Through three roles. From each word, the model produces three vectors. A query, what am I looking for? A key, what do I offer? And a value, what do I actually carry? Think of a search. Your query is matched against every key, and the best matches return their values. Attention runs that search for every word simultaneously. To find the matches, take one word's query and compare it against every word's key with a dot product, the similarity measure from episode 10. A big dot product means this key strongly answers my query. The result is a row of raw scores, how much this one word should attend to each of the others. Relevance as numbers. Those raw scores get passed through Softmax from episode 2, turning them into clean attention weights between 0 and 1 that add up to 1. Now there are proper distribution of focus, maybe 70% on one word, 20 on another, a sprinkle on the rest. The model has decided softly where to look. Finally, use those weights to blend the values. Take each word's value vector, multiply by its attention weight, and add them all up. The result is a brand new representation of the word, one that has literally absorbed information from the words it attended to. The output of attention is context, mixed in. When a sentence does this to itself, every word attending to every other word in the same sentence, we call it self-attention. Each word updates itself based on its neighbors and its distant relations alike. After one layer, every word's representation is enriched with the context that's relevant to it. That's the heart of the whole thing. Make it real. Take the sentence, the animal didn't cross the street because it was tired. What does it refer to? A human knows instantly. The animal. Self-attention learns this. When processing it, it places high attention weight on animal, pulling that meaning in. The model resolves the reference by looking directly at the right word. And here's the payoff that beat the RNN. Every word's attention can be computed at the same time. It's just one big matrix multiplication, the very thing GPUs love. No waiting for the previous step, no sequential chain. Attention is fully parallel, which is exactly why it trains so much faster on modern hardware. And distance becomes free. Whether two words are neighbors or 1,000 tokens apart, attention connects them in a single step, one dot product. There's no signal to fade along a chain because there is no chain. The long-range memory problem that plagued RNNs simply disappears. Direct access, learned focus, full parallelism, and no distance penalty. Attention solves every weakness we listed last episode. It is the single mechanism that made modern language models possible. Stack it up the right way with a few other pieces, and you get the architecture that runs essentially all of today's AI. So that's attention. From every word, send a query, match it against all the keys, turn the scores into weights, and blend the values. Each word gathers exactly the context it needs, all at once at any distance. It's the most important idea in modern AI, and next time we assemble it into the architecture itself, the transformer. See you there.